going to be any second. And boom, we're live. So welcome back, everyone, to another AI Journal LinkedIn Live. And we're slowly moving this over to YouTube Live as well. So I have to come up with a new name for it. But really excited today to have Dr. Radoslav on the show. Rado, how are you doing today, sir?
Very good. And thank you very much for inviting me.
Pleasure. I'm really excited. I was just saying as we're getting warmed up here, how I'm really excited to touch on this area. We're going to be looking at around universal processors, universal processing, quite an interesting area. And I feel like you're going to have a lot to teach me in this time we've got together, Rado. And I guess what I want to do to start off is get a bit of a background to who you are, Rado, and the reason behind Tachyum. Actually, on top of that, I'd also, as a third part question, love to know where the name Tachyum came from. So who you are, what your background is, and a bit more about Tachyum, please, Rado.
Sure. I'm Rado Danilak, co-founder and CEO of the Tachyum. My previous work include, creating storage system for military intelligence, and it was acquired in 2014 by Western Digital. Before that, I was founder and CTO of SendForce, which started SSD revolution.
Yeah.
MacBook Air, Apple, and others have been our exclusive customers. Before that, a company you might know called NVIDIA. My last project, which I was at beginning at, was NVIDIA Fermi. Was behind chief architect of Enforce 4 for Intel Edition. Some patents on NV50. More than 120 granted patents, more than 100 pending. Before that, Toshiba, we did a processor for Sony PlayStation 2 Emotion Engine, and a lot of other funny projects.
Wow, that's cool. And where did you get the name from then? How did you come up with the name for Tachyum, and where did the idea kind of stem from or flow from?
Sure. Probably everybody knows word tachometer, tachycardia, and so on, which is from Greek speed. And is like material, like strontium, calcium, magnesium, and so on. So it's kind of stitched together as the material of speed or fastest material, and it's pronounced tachyum.
Tachyum. Sorry.
Like
tachyum.
like tachometer.
Tachyometer. I like that.
Yeah.
That's cool. Tachyum. That's cool. And so I want to go into a little bit around what it is you're doing and your kind of experience, like you're saying, on previous roles and previous companies you worked with, and what you're building now, and everything that's going in it. So I saw that you launched something called Prodigy. Did I get that right? Prodigy.
Correct.
And it's a universal processor. It does universal processing. Tell me a little bit around that. Why you why you launched this Prodigy, and B, what is meant by universal processing?
Sure. So today people are familiar. They use microprocessors, in servers, laptops, and so on. Our focus is basically cloud, so is the servers, and they run the servers applications. Now, for high performance computing, like supercomputers, people use GPU, general purpose part of the GPU.
Yeah.
And then for AI, they use various accelerators. Now, we ask few questions. Why to have three different chips? And we will talk the issues with having three different chips. Can we unify it, not just put three pieces on one piece of the silicon, three technologies? Yeah. And the idea was simple. Like, some people remember many years ago, we had processor 386. Yeah. And that was 387 was mathematical coprocessor. And since 486, they got integrated, and we have forever them as one device. So our question was, can we take microprocessor and improve it and extend it such that we can have very high performance computing, and we can kind of replace GPUs. And it's kind of not new, I would say. Some people remember that supercomputer starts as vector processors. The GPUs came much later to it. And the reason why people used GPUs because it's better performance per dollar and per watt. So it was economy. Programming was hell, and is still hell of GPUs. Yeah. So what we did, we extended CPU, vector processor, remove inefficiencies, extend in vector length, and basically to achieve performance at the GPU level at better cost and power. Now, I would say we are not only one in that aspect. If you look at Japanese Fugaku supercomputer, world fastest, it's based on ARM with vector extension. So basically, this is just vector processor or vector unit in CPU done right. Now, once you have vector unit, you have a lot of multiply add units, and you work with a lot of data. So the question was, can you also just basically subsume AI? AI is using smaller data types like 16-bit floating point, 8-bit floating point, and but fundamentally is producing floating point results. But most importantly, it also works on matrices. And let's explain why. If we have just a vector processor, which has 64 elements, unit has 64 elements, and you do multiplication addition, you do 64 multiplication, 64 addition. Makes sense. But now let's come with crazy idea and don't view it as 64 element. Let's view it as matrix 8 by 8 elements. It's still 64 elements. It's just question how you view that. And from college math, we know if you multiply matrices 8 by 8, you don't do 64 multiplication addition, you do 512 multiplication addition. So amount of computation is amortized compared to overhead, rest of the chip by factor 8x. You do 8 times more computation, so your overhead of the CPU becomes 8 times smaller. And it diminished to the level that basically the overhead is comparable to GPU. So that's how is achieved the burst performance. The last point what I will make, that GPUs run at like 1.3 gigahertz, 1.4 gigahertz. So if you run at 5.6 gigahertz, it's 4 times more. The single unit, which is doing multiplication addition, producing 4 times more results, is running 4 times faster. So you need 4 times less of them. So end up with half the chip size and so on. That's one point. One more point what I will make, who cares about basically universal processor? What's the value? What's the benefit? And let's make example on company which some love, same hate, and almost everybody is using, called Facebook. Facebook have massive data centers, tens of $billions of the machines. And what they publish the graph, how it's used. There are resources over 24-hour cycles. And, around midnight on the West Coast, 3 a.m. on the East Coast, most normal people are sleeping. So 95% machines are idle. Around lunchtime, everybody's on the Facebook. But over 24-hour cycle, they use less than 40% of these resources. And they cannot use it for AI training. They have to use GPU because CPU is so bad at AI. It's cheaper to buy the GPUs around 24/7. But if you have chip which can do not only CPU, but equally effectively can do AI, you don't need to turn off the servers. You can use them for AI. And instead, 6% of GPU, what you have for AI training, for free, over 24-hour cycle, you have 60% of equipment which was not used otherwise. But if it's universal, you can use it. So you can get 10 times more AI, and you don't need to buy any GPUs. So it's for free because you already paid for the servers. You just utilize them much higher. Does it make sense?
Yeah, it does. I just got one question onto that. So just to elaborate a bit more, please, Rado, with AI training. So how I think you were mentioning it, and it was a really good answer, but I just want to check how the AI training is a part of this. What does that enable it to do? Just to reinforce what you were saying. You're saying it brings it down by 6%, and
So basically, how it's done today. Again, Facebook has CPUs, and CPUs they do only AI inference to build your web page and make your recommendation, but they don't do AI training. And they are used only less than 40% over 24-hour cycles. Now, on our chip, you don't need to do only inference. You can do also training, because inference on Intel is done like on 8-bit integers, which you cannot really training that. You need like floating point for the training. So we have 16 and 8-bit floating point, which is needed for AI training. And it costs us only like 5% of bigger chip because we have them. But because you have that, now you can run training on the CPU because we have small floating point data type, enough performance. So by fixing these things at 5% bigger chip, suddenly you can use for AI training and you don't need the GPU.
Yeah, got you. And that makes it, would I be right in saying that's much better? Well, I imagine the first part, right? But the first part being much more better for scale and much better for understanding and being able to shift it to more. But the second part, and I think this would be more accurate, is for greener. So it's a lot better because obviously
Absolutely.
you're not, is that right?
Yes, because you can do more with less. So supposedly somebody calculated that there is almost $300 billion of IT equipment on the earth.
Yeah.
And which is used less than 50% of time. So if you can double utilization, you will need half of the materials, you need half of the rare earths, or expensive materials which are more expensive because a lot of them are in Russia. So doing more with less is needed, and that's the way we solve the obstacle. Today you cannot use one thing for other purposes, so you have multiple pieces of equipment. You can unify, you can do much more with less.
Yeah. And that's such a key thing today, right? With the amount of technology and the amount of shifts and the amount of digital transformation and people really investing a lot of money very quickly into these areas, right?
Exactly.
And so to take it a step further, I've heard you mention, I think I heard you mention CapEx-free AI. What is that? What's CapEx-free AI? Give me at least.
Explain.
You've never told me before and the audience never heard it before. What is it, Rado?
Sure. So we already talked about that. And the idea is that, today you have CPUs, servers, and you buy GPUs for AI training. We just talked about that.
Yeah.
And the CapEx free means capital expenditure, you will not buy the GPUs. The reason why you don't buy the GPUs, because the universal processor can do both, and you already bought the servers which are not fully used. So instead of buying new GPUs, you are just running on equipment what you already purchased. So that's why it's CapEx free, because you don't need to buy the GPUs. You're just using the resource which you already bought for different purpose.
Yeah, I love that. Like renting instead of buying, and you just need it for usage or usage based, which I think is better. Like usage based over license based, which
reducing waste. Things which they are turned off and all this money are wasted. You are able, because universality, to use it for additional purpose.
Yeah. And I guess have you seen how companies, and obviously I don't know how far if we can go into this, but have you seen how that's really had an impact on companies or had an impact on an industry, or what that's kind of led to as this happens?
Sure. We are not yet deployed in production. So what we see, how the customers react to it and what they tell us. And what they are telling us that it saves them money by not buying GPUs and having utilization higher. They believe that capacity, which is today wasted by turning off the servers, that they might give them opportunity to rent as high performance computing to third parties to make more money out of their underutilized existing equipment. So the belief is that few years down the road, when the universality will be required and prevalent, basically we will need less resources to do more, because instead 40% in 24 hours cycle, the equipment will be used 80%, twice as much, which means you need half equipment.
Yeah, I love that. That's really cool to see. And I guess that really means like companies that have this angle of like improving the bottom line and making it better, it frees them up resources. So it brings in, like I was saying the other day, it allows if you've got an R&D department, for example, it frees up that resource to see what else can we do. Now Tachyum's coming in and really saving us on our data center costs, right?
And it's actually some other interesting angle is, and we go back to the Facebook, you have this equipment which is used at 40% of the time. So if you are able to do AI, you can do 10 times more AI, which without paying for it. So that I'm sure they will find all cool stuff to be used for that AI. So it will enable, because it's so cheap, AI, and basically ubiquitous. It's effectively for free because you already pay for the servers. We don't even know what will be the impact. Like we did not know when these crazy things called iPhone showed up. We did not even know that today you will be measuring your blood pressure with that, and Siri will work and so on. So similarly, it's hard to say how the impact will be. We know it will be big. 10 times more AI in this world should make the impact.
Yeah. So do you think, because I've got a pair here, I've got these, these Google Glasses. So they're a very prototype edition. Like they're in production, they're being used. So Google Glass, and they're pretty cool, and like the applications are pretty cool. Do you think things like, and I kind of guess the answer, but if I can ask you to elaborate a bit, Rado, items like these, so you said like the iPhone, the glasses coming out, and there's an area like quantum computing is becoming massive, and the amount of energy that's taking up, and you see like the data that needs to, all these new applications basically that need physical space. Is this a correct question? How's this impacting it? How can that help? Or how do you see it changing with all these new things coming in, Rado?
See, good intelligence, artificial intelligence is not cheap. It's not few dollars.
Yeah.
Series is big machines being done. And, if you have some device, you have your glasses, or you have simple toaster, which will have AI and so on. In these devices, low-cost devices, it's hard to pay for good AI of Siri-like,
Yeah.
But it will have benefit. Your toaster will see camera, make sure it will not burn. You can tell him, I need to go, so make something, and things like that. And how you put $1,000 AI Siri to toaster, you will not. So the way it would be done, that you will have AI on the cell tower, and then basically all these devices, they will use intelligence, borrow as they need, because if somebody talks for 30 minutes to toaster per day, I think he has bigger problem. He might need something maybe minute per day, 30 seconds per day. So by sharing through the 5G with 1,000 devices, that basically you can have $1,000 AI quality and good interaction, but because it's shared between 1,000 devices, it's really costing $1. So we believe that AI can help everywhere. In the glasses, can help with people like engineers, which they are kind of socially impaired, to basically tell you, oh, that's that person. And by the way, you talk with him that time and so on, and basically assisting the people to have better life.
Yeah, because I've seen that with these. These are like the applications I was getting shown was in the food industry. So they're being rolled out massively along the food industry, especially for fast food as well. So whether you agree with eating fast food or not, it can be a tricky situation to learn the ropes very quickly. And they've got a massive, I don't know whether it's big, and I don't know, but they were explaining whether it's because of the margins of the business and that industry itself, training someone up to speed, if they're on the shop floor.
Labor shortage. There is labor shortage in US.
Yeah. So it really helps with the training aspect. And if they can get that quicker, I think it's a great point. But Rado, I'd like to ask you then, and I think I'm getting this right. Can you explain how, or does the cloud have any impact on what you're doing and making sure that it moves between the cloud and how the data gets transferred? Is that a good question? How it goes between maybe a private cloud or a public cloud, or what happens there?
Sure. People are using private cloud when they work with sensitive data, or the scale is such that the public cloud is expensive, and public cloud is more ubiquitous. And, public cloud serves public. That's why it's called public cloud. And basically, a lot of services are attached to human consumption. When people are sleeping, they probably don't shop on Amazon. People are sleeping, probably they are not doing Google searches, or probably they are not watching Netflix. Maybe you can run the Netflix while you are sleeping. Maybe it's better than the sleeping pill. But the point is, a lot of these resources are attached to human activity. And what you will do is that if basically people are sleeping, you turn it off, but instead, the capacity can be rating as supercomputers. So basically, scientists and academia, they kick their job, and the job waits until people are sleeping, and then equipment is used. So the academia will get, for much lower cost, a lot of performance. And again, the vendors who they have cloud, they get more money from their equipment. They do more with less.
More kind of research, I guess, more kind of understanding. What do you mean from the academia side?
So basically, academia and researchers are using supercomputers or high performance computing to do development of vaccines or simulation physics, research in cosmology. And, they buy the supercomputer, they pay their full price, and they use it. use them. And there is not enough supercomputer capacity. If you have twice as much, they will be happy to use it, except the money are fixed pool. Now, if they can, instead buying supercomputer, they can use the capacity in the night in the cloud, that cloud is not serving people, well, they can get it probably for half or third price. So both people win. The cloud provider, they got extra money because somebody in night is using their machines, and the researchers, they got it cheaper because basically the capacity is kind of available for them for free, so they will be probably at discounted rate. So everybody wins.
Yeah, I like that. I like the idea that everybody wins as well, because you've got a software ecosystem, right, at Tachyum, and how does that work? Like, how important is that to what you do, or to how you can run these awesome ideas and these awesome technologies like Prodigy, or technologies like Prodigy? How does that technology ecosystem work?
Sure. The software ecosystem is very important. I would say even most important aspect, because whatever beautiful machine you have, if nothing can run on it, it's kind of just paperweight, right? So the software is absolutely critical. And, bringing new platform is always, maybe what you say in Britain, a royal pain.
Yeah.
What it is. And, I remember that I worked at NVIDIA when we start pushing GPUs in compute space. And it took many years to get sufficient software running. And for startup, that would be kind of not survivable point. So we built our architecture in the way that from day one, you will be also able not only run our applications, native and AI and things like that, but you can run also legacy existing x86 applications, or your Linux Intel applications. Of course, maybe 30% slower than native, but from day one, you will be able to use our chip. So the software is absolutely critical. That's why we have more software engineers than hardware engineers in our company. And we had to build, and we built all necessary pieces, from like BIOS, from compiler, to making sure Linux runs, FreeBSD, PyTorch, databases, and you can find on our website the list of native applications. And then we also are able to run existing Intel applications in binary translation. This is kind of like if you buy a new MacBook Air, the very thin one, I love it. It doesn't have Intel processor. It has ARM processor, but you can still run your Office. And how it's done? They have technology called Rosetta, which simulates Intel processor on ARM. That's why you can have this beautiful machine without heavy and power-hungry Intel processors, and they are beautiful machines. And again, it was achieved through the technology called Rosetta. We have technology based on QEMU, but the concept is the same. It allows you to work on new cool platform, more efficient, which you like more, but it runs your existing stuff. So basically, you are not suddenly disconnected.
Yeah. I really like that. I think that's cool, because a lot of the things when I buy a new laptop, you kind of get, or not duped, but you have to check if everything will run on it, and if it does do it. And I don't know how. Like they said in not these ones, and I said this on another podcast the other day, that the Apple glasses, and it's a rumor, I don't know for sure, and I'm not saying this is what's going to happen, but it's estimated from a source that usually gets most of them right, that the glasses are going to have more power, more CPU power than a MacBook Pro with inside the wireframe of glasses. How the hell is that possible? Like, and it's going to move as quickly, it's going to process as quickly, and you think, is that from sharing the data to the cloud? What do you think, right now? How does that work?
So, that must be with some assumption. Let me tell you why. Because
that's a rumor.
Your compute performance, they will use same manufacturing as, MacBook Air chip, probably 5 nanometer, 3 nanometer. So the new manufacturing doesn't give them more performance per watt. So basically, what you can do, your computing is limited how much power, how much you can drain the battery. So I think they will be limited by that. So, but to get this high performance AI, high quality AI, likely you will have some compute to do basic things, but when you need really a lot of horsepower, probably it will communicate through 5G to cloud to get that assist. Like,
Yeah.
when you have phone and Siri, you talk to the server, you talk to big machine. So I think it will be combination of compute, whatever you have, which is limited by battery, and MacBook battery maybe is 1 pound. You cannot really put 1 pound to your glass. You can't. So probably that communicates with something what you carrying on you, but the performance is limited by the battery weight. So if you will have more compute than a MacBook Air, then probably you need similar battery, unless you do some specialized things that you create special hardware just for particular special AI. Then you can be like 3-4 times more at same battery. But in general purpose computing, there is not really much room for doing black magic or white magic.
Yeah, I like that, black magic and white magic. That's a good way of looking at it, Rado. And what can I ask? What do you think about quantum computing? Is that something you look at, or you have much of an opinion on? Is it an area?
Well, quantum computing was 20 years ago. This year and 10 years from now will be technology of the future still.
Yeah.
Now,
really, 20 years.
No, let's think about the usage. It will be used more and more, but quantum computing require that stuff is really cooled down to very low temperatures. Minus 270 Celsius,
Yeah, I
or
heard about
few
that, how
Kelvin.
low it has to be, and like someone did a quiz, and it's like
how you get it into iPhone? How you get it into glasses to cool down? The answer is you will not. So the quantum computers, they will have own space. They will be used for narrow applications, and it's unlikely it will be portable applications, because the problem is, the chips can be very cool, but 30 pounds of the refrigerator on your bag is probably not great thing for iPhone or iWatch.
And it's not very good for your health if you have to carry that around.
Exactly. So the quantum computers looks like will be used in the data centers with cooling, and applications are limited. So 10 years from now, you can say that 99% or more than 99% of computers, your laptop, your iPhone, your glasses, or iWatch, will not be quantum based. It doesn't mean that they will not be in data center for certain applications.
Yeah, that's a good point. I've never really thought about that. Someone was saying the other day that with the whole trip to the moon, and I was at Web Summit, and they had like a NASA engineer talking about that it's time. Like there was a whole headline, "It's time to go back to the moon" or whatever, as a partly PR and partly correct. And he was really encapsulating. And so I was speaking to someone afterwards, and they were like, "Yeah, the only reason we're going to the moon is to build more data centers. We're going to build the whole moon data centers because there's not enough land here at the moment. Everything we're doing," which I thought was a funny argument. Obviously, I don't know if that's what it's for, but it's quite crazy, right?
Yeah, sending people to moon, it's long time dream. Now sending certain people to the moon probably will make Earth better, but we cannot afford that, so we have to live as we live.
Yeah. Would you go to the moon, Rado?
Probably no.
Why? It's not really on my agenda either. It's like,
exactly.
It's I've got other things to do here on planet Earth. I've got things to crack on with. So we're looking at it as well. So if you look at what you're doing at Prodigy and what you're saying with the tech ecosystem and everything we've discussed now, Rado, what is it about? What do you reckon the success is going to be from, or what successes do you think we'll have from these lower CO2 emissions? What kind of things will be as a kind of relay from that, and how can you see that being helpful for people? Because obviously if they don't need as much space and don't need as things, it's not going to mean much area that they need. Is there anything else alongside that you want to add? Or
sure. I don't know how many people know that in 2019 3% of planet electricity went to the data centers, and which is, by the way, more than whole UK consuming, and produce more CO2 than all airplanes on the Earth. And that's not the scary part. The scary part is it's growing at 15% per year. Which doesn't sound a lot. It's a lot, but it means that by 2040, which is not that far away, we will end up with more than 40% of planet electricity in the data centers. So that will be definitely a problem with global warming and the resources and so on. So, we need technology which gives you more performance but at lower power. Otherwise, we will cook this planet, and that's not what really people want. And
Yeah.
same time, they don't want to stop using Facebook or go back to black and white pictures because we don't have enough capacity. So the solution to the problem has to be technology, and using our technology. From today, 4% planet electricity will not get to 40% in 40 years, but it will go to only 6%,
That's cool.
which is survivable.
Yeah,
So,
yeah.
so performance per watt, data centers, very few people realize you can view them less than 20 years threat to humanity. So
Yeah.
it needs to be done more with less, more compute with less energy.
Yeah, yeah. That's such a cool. Thank you for sharing that. 'Cause I had no idea that was the kind of route we're going down. Because everyone looks at fossil fuels, right? And I know a certain fuel provider got in the press because of someone leaving, and it's just looking at it like, well, if you look at all that angle compared to looking at the angle of like what electricity is doing, like people say, like Bitcoin is just going to be chaos regardless of whether you buy it, sell it, hate it, or love it. Like the logistics towards it, it's
Yeah.
terrifying. Like how you think. I heard someone say the national grid system in the UK would struggle if everyone put their toaster on at the same, or everyone put their kettle on at the same time. Let alone like alongside everything else, of course. Let alone trying to power all these supercomputers and super areas.
Well, even if you can power,
Yeah,
this current trend of the prices, a lot of people might be really squeezing them and affording to basically heating in the winter and so on. So I think the energy costs are going up crazy way.
yeah.
So yeah, the problem is bigger and faster than we thought.
Yeah, I think so. Because you had those problems like in Austin, was it last year? Was it Austin where they had the power outage and then they got hit by a storm? And you think like all the angles off the back of that, Rado, like all the potential or all the things that did happen that you might think about but you can't predict. It just showed how open to or how not secure it is and how it's open to threats that we can't control.
And actually, it's not just they did not have power.
Yeah,
Very extremely sad thing happened.
yeah,
More than 200 people died and froze to
yeah,
death. So
yeah.
it's more
Horrible.
than inconvenience. It's really something which is
Oh,
bad.
yeah. Well, you look at all the people that like the hospitals failed, right? Like the power shut down, and once that's
Yeah,
down, and once police force is down, all those kind of things, it
yeah,
can be if that happened across the country, you'd have a real catastrophic event on your hands. Like, and it is. I never say something's never not possible. It's always going to be possible. Like if it's possible to light everything up and keep everything powered, it's possible to unpower it all. Like obviously it's quite hard, but
yeah. Actually, I think in US, I think today's day or 2 days ago, the Biden invoked basically act and declared that basically power emergency, and they are worried that during summer, basically the all AC cannot run because it will create rolling blackouts.
really, that's
Yeah, it
crazy.
was in the news recently. I think 2 days ago or something. Yeah,
Yeah. And I get, are there any other angles you would say? So obviously, like what you're building is awesome. That's why I said before coming onto this call, I was like, I really love what you're building. It's really cool from the eco side. Do you reckon there's other things for companies that they need to consider alongside what we've recommended here and what we're discussing here? That well, maybe not recommend, but things to consider. I never want to say recommendation, but things to
sure.
question or consider or to do things. Yeah.
Every technology, it's scary at the beginning.
Yeah.
Uh, and when the cars came to market, somebody had to run with the flag ahead of the basically car and wave,
Yeah.
because everything it's scary and it takes adoption time. And you know it's important to look to be prepared to be adopted, and every technology has a teething pain initial. So
Yeah.
what my recommendation will be to really study, think about the power consumption, performance, doing more with less, and look at the strategies and evaluate the right technology. And if you think you find something beneficial, just play with that, and think where it will be beneficial for you to be deployed. And everybody has to think from energy, doing more with less, and things like that. That's the nature of these days.
Yeah. I think that's a really great point, Rado. because I struggle from it from a personal point of view. Like I'm trying to be carbon neutral and probably not. Like I'm trying to be and I always try to consider it and I always try to think about it. But I always think at the same time, how imagine taking Amazon Prime away, like next day delivery. Now we've got it, everyone wants it. And you think, how do you keep that without having the implications? Because I heard that they were like one of the, it was some, I'm paraphrasing, but that they were one of the biggest consumers of fuel and electricity because all the like it's a huge global logistics operation and shipping and all the things that fall under them. But it's like, how do you keep those technologies, the thing we love, the things that power our lives, the things that allow us to keep connected like this, while trying to offset? It's such a hard question. I don't know. I always struggle with that. But we've got a question from the audience, if you're okay to answer it, Rado. A couple of questions that have come in. So one of them from Mike. Mike's a great person. Mike said, with the advent of AI edge processing, do you think solving power consumption or self-generation power will be an important factor in future adoption and growth, which we kind of touched on, but I don't know if you want to add more specifically to this question.
Sure. AI in consumer devices means it has to be small and has to consume not a lot of energy. Now, if you use 5G to deliver AI to your devices, you have only so much power on the cell tower before it will be overheating, and definitely cell tower is basically edge. So the power consumption is important, because if you are limited by power, you have twice as much intelligence and you have fixed power. Well, you need to get it more efficiently. You don't expect cell tower to produce self-generate a lot of electricity. Probably you can add some small solar panel, but it's unlikely it will be able to cover its energy. So the consumption, reducing consumption, is really paramount.
Yeah. So how, and just quickly off the back of that, so you're saying like through towers, keep it to the edge, and through cell towers, how do you reckon there's a better way to do it? Or how important do you reckon are they to making sure this all runs smoothly, Rado?
The power is limiting what you can do there, and the compute might have tendency to move to your cell tower, and the reason is, you talk about the glasses. If your glasses for your assist has to send things to Arizona and back and project augmented reality for you, you will get motion sickness with the delays. You want to be really close and really to the compute will be on edge close to you, because latency matter.
Yeah, you won't be able to do a job if you've got seasickness or motion sickness when you're in a
exactly
factory.
And if you have delay in gaming, hundreds of milliseconds, you get motion sickness.
Yeah. Well, I've had that before. I don't want to play because I'm just like, over the lockdown, like that's what I
so you have to have compute close to you to reduce the latency.
Like stick it into Ethernet cable or something to speed it up if you want it direct access. Yeah, that's a great way of looking at it. So one more question as well. So from Mike again, in light of more AI processing power in most devices and increase in data, where do you think electronics will evolve in the next 5-10 years? That's a great question. I was going to come to not that question, but something similar afterwards. But what do you think, Rado?
Sure. Everybody was scared that the Moore law is ending, and they've been raising issue how you can get below 10 nanometer and so on. So good news is that we know what to do for 3 nanometer in 2024, and what to do in 26 in 2 nanometers. And so for next 10 years, the good news is the industry, it will be more expensive, but it will not hit the wall. So next 5 to 10 years, we can continue to see improvements, more intelligence, and after that, some new inventions will be necessary to push us through the wall. But so far, we have been able to push it, quite far. And I think the next 10 years, we don't have anything fundamental showstopper to continue evolution.
Yeah, I think that's a great answer. And I've got one more question for you then. I know we were talking about this earlier. I know I said I don't want to repeat it, but I just want to be clear for the audience. How does Tachyum, with your different products, so you've got the Prodigy coming out, you've got the Prodigy FPGA emulator, the software emulation systems, and the TPU. Is there any way that they all merge into each other and all collaborate with each other, or are they all kind of separate to if a company uses them, or is there a lot of channels of collaboration between, and especially with Prodigy coming in and being a POC and coming to market?
They are a kind of stepping stone. The product is one, is the chip prodigy, and as you are developing, product, you need to start bringing software. So when the chip will be there is enough software. That's why we create software emulation. So even without having chip today, you can run and debug and test applications. So when our chip will be available, basically, you can deploy it. So that's first stepping stone. Second stepping stone is FPGA. This will be not product. The FPGA is kind of like you have this FPGA, which you think about universal chips, which you can program any function. So before you create your product, you burn function there so you can test it, so you can find the bugs and fix them. Because if you have a bug in silicon, well, it takes 3 to 5 months to correct, and it costs $30 to $60 million. You cannot, like software, go and fixing bugs. You will be dead.
Yeah, eat up all your expenditure as well, like the costs on top of that.
No, you will be dead. You will not have product at a reasonable time. It will just not work.
That's crazy. No, that's crazy, and that's a great way to look on it as well, to finish up this great conversation. So, Rado, I really appreciate you coming on, because this is a topic I think I was saying before that I'm not 100% familiar with, but you've really given some great answers. And we've got one more question, sorry, that's just come in. Are you okay to answer that as well? And thank you, Eric, for this question. So Eric's come in, bit of a long question here, which is good. The use of AI has revolutionized many industries by reducing costs and increasing efficiency. Is there a chance that AI technology itself can advance to a point of applying the technology itself to lower power consumption, but working most efficiently, which we touched on a bit earlier? But what do you think, Rado? Anything to add?
Well, sorry, it's too late. It already happened. So let me give you examples. For example, software tools, EDA, electronic design automation tools, in designing chips, they already use AI to basically improve parameters, speed, and power consumption. Now, also, there is company called Good AI. I know their founder, where their AI is very interesting because AI is changing, improving itself. So AI is improving AI. So such technologies already we can see and will be more and more prevalent to basically self-improve. But it's already happening, it's already there. There are examples of this happening.
Yeah, awesome. Really appreciate answering that. And thank you to Eric and Mike for putting the questions in. That's been a lot of some good insight that hopefully helps you. But Rado, really appreciate you having on. Excited to do this again, hopefully in person when we're both over in America. And to everyone joining us, many thanks for coming on. And as always, let us know if there's anyone you want us to interview and bring the great minds, the people that know about this, such as Rado. So thank you again, and really appreciate your time.
Thank you very much for listening.